This is section 4.1, and this is about polynomials. In the first part of this, we get the math idea of what a function might look like, but I think you're used to seeing them like this. This is an example. And what we want to really understand is that the domain of all polynomials is all reals. There are no restrictions. X can be anything in the world. We also want to note that exponents should be integers and positive. This little box shows us what exponents can't be in a polynomial. We can't have a fraction, we can't have a radical, we can't have a negative. If you're looking at the graph, they're going to be smooth and continuous with no breaks. So all of that right there is information about what a polynomial should be. The degree of the polynomial is the highest exponent in the line. In other words, up here, you have a 3, a 2, an understood 1. This is a third degree. That's the highest. So here, the degree would be what? 4. 4 is not it. Even though it's first, you have to look through the line because they're not always in descending order. So 5th degree. In this one, you have to make sure that you understand you would be multiplying these two, so it would be 2x times x squared, which gives you x cubed. The degree would be 3. So we might try here and just get some examples. If you had f of x equals 5, that's like y equals 5. That's a horizontal line. The degree for that one would be 0. The degree would be 0. And the leading coefficient would be 5. It's like an understood x to the 0 here. G of x equals 3x minus 5. The understood exponent right here is 1. So this is a first degree. This one would be a second degree. This one would be a fifth degree. So you just look for the highest exponent. If there's not even an x in it, that's a 0 degree. If there's an x but no exponent, that's a 1 that's understood. So we're going to look at some special polynomials, and these are power functions. First degree, second degree, third degree, fourth degree. And just in general, that's ax to the n. And a few parameters. A must be a real number. If this isn't real, you're not going to have a polynomial. And a can't be equal to 0. Why would that be? Well, if this were 0 and you multiplied it there, you would end up with 0 and you would no longer have a function like that. N has to be greater than 0. So our exponent has to be bigger than 0. If it were 0, anything to the 0 power is 1. So those are just some general things about that. And the basic one, like this, if it's even, contains negative 1, 1. That's right there. 0, 0, right there. And 1, 1, right here. Now, you start doing things to it, adding numbers, taking away numbers, that sort of thing. That doesn't necessarily hold true. But in your basic one, like x squared, or x to the 4th, or x to the 6th, that would be true. And it is symmetric with the y-axis. Here's the y-axis. That means it's the same on both sides, okay? Now, if our function is odd, it's still this power function. But if it's an odd degree up here, we have those same general parameters, but what we're going to have is negative 1, negative 1. So instead of it being up here, we are down here. And the other two are the same. So you get this look. That's like an x cubed, x to the 5th, x to the 7th. No longer is it the same on either side of the y. It is symmetric with the origin. And you can tell origin symmetry if you take this thing and, like a spinner, spin it around 180 degrees. This top ends up here, this bottom ends up here, and you have the very same thing. So that is symmetric with the origin. Another couple of things that we might talk about here is increasing and decreasing functions. Increasing means from left to right, you're rising. Decreasing means from left to right, you're falling. And so by definition, a max occurs when it changes from increase to decrease. Let's think about that. We're going along, we're increasing, whoops, increase, increase, increase. We hit a point that changes and now we're decreasing. That point is a max. Here, we're decrease, decrease, decrease. We hit a point where it changes. Now we're increasing. That is a min. So as a possible problem, if you were given x cubed plus 5x squared minus 2x plus 7 and asked to find where does it increase, where does it decrease, we could put it in our calculator. And when we did, we would find this point and this point, the max and the min. And so where is it increasing? It's increasing here in yellow and here in yellow, so that'd be 2 places. And it's decreasing in the blue. So if you have a question that asks you, gives you a function, asks you to find where is it increase, decrease, you know that you can put it in your calculator and find the max or the min. And you should have been able to do that in college algebra. We'll probably talk about that more. And then it is increasing here from negative infinity up to this x point, and from this x point to positive infinity. It's decreasing from this x point to this x point. So that's how you would do that. Let's see. Real zeros and multiplicities. The multiplicity of a real zero is the number of times its corresponding factor occurs. So if you look at this one, here's a factor, here's a factor, here's a factor. This 5x to the second power would just give you 0 as one of your solutions or your zeros. And that and on that one, there's an exponent of 2, so it has a multiplicity of 2. So 0 has a multiplicity of 2. This one, x would be negative 2 if you solved it, and the exponent here is 1, so it has a multiplicity of 1. If we solved this one, x is 1/2 with a multiplicity of 4. So those are repeated roots. This is not a repeated root. It has a multiplicity of 1. So that may come up in our questions. Then we want to talk about turning points. That's just other language to talk about your maxes and your mins. So the points at which a graph of a function changes direction. So think about it. If you are going up, 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 and then you changed, that point where you changed was a turning point. And there's a theorem that says if f is a polynomial function of degree n, then that has at most n minus 1 turning points. So if you had, let me see if I can draw here. So if I had that, all right, how many turning points do I have? I have 1 here and 1 here. That means that this says then the graph has at most n minus 1 turning points. Well, if it has 2 turning points, it would be a third degree. That looks like a third degree. So the degree is going to tell you at most how many x-intercepts you have and what the degree is. And then one less than that would give you the turning points. So if you know the turning points, the degree is 1 more than the turning points. So that's what that does. And that would give us our notes. We're going to look at our problem set worked out. Okay, the first one says find the intercepts of the following equation. And they gave us 7x squared plus 9y equals 63. Well, we can use our calculator on this if we want to, and that's probably the easiest way to do that. So we're going to solve this equation for y. I'm going to move the negative 7x squared over here. I'm going to divide by this 9, and I ultimately give this as my equation. And then I put some screenshots here, but just for this one, let's go here to the calculator. And so I put that in under y1, and I put 0 in for y2. Typically, if you don't know what your window has been and you want to be at a normal standard window, you can do zoom 6, which is a standard window. And so I get this. My solutions end up here and here, but I am looking for the x-intercepts and the y-intercept. So if I want to find the x-intercepts, you might can see them, but to be sure, if you've got y equals 0 here, you can do second calc intersect and hit enter 3 times. It pops to one of them, so that's x equals 3. To do the second one, second calc intersect, but let's move to the other side of that. You don't, as long as you pass that max, you could stop and hit enter 3 times. 1, 2, 3, and we've got the -3. Now to find the y-intercept, you can go to second calc value, which is number 1, and it says what x value do you want? Well, at this point, x is 0. So if I type in 0 and hit enter, it gives me y is 7. So that's a quick way to get the answer to that question. It does want them in ordered pairs. Be sure in your homework that you read these directions. It will save you a lot, because if you do not put them in ordered pairs, they're going to count it wrong. So please read the directions. Number 2, is this thing polynomial? If so, what is its degree? And we look at our x's. Now, this radical throws people sometimes. This is just a number, does not have an x tied to it. So that's just a number. These exponents are fine, and this is a polynomial of degree 3. The graph of every polynomial function is both blank and blank. We talked about that in the notes, smooth and continuous. Number 4, if r is a real 0 of even multiplicity, then the graph of f touches the x-axis at r. Let's go back to the notes and look at something there. So here was a chart, and I didn't talk about it, but if we look at this function where it crosses the x-axis, that is odd roots. This shows that it would be an odd multiplicity. But if it's an even multiplicity right here, it touches the x-axis, doesn't go through it. So the odd ones do go through right there. Both of those cross. That one crosses. This one just touches. That's where you'll have one of those repeated roots. So let's go back to our problem. That one was that one. Number 5, the graph of power functions of f of x equals x to the n, where n is an even integer, always contains the points. And you have to choose from these choices here. And remember, it was -1, 1, 0, 0, 1, 1. That's just pulling information from the notes. You may not have that exact question, but that's kind of what it's talking about. Number 6, select the word that completes it. The blank of a real 0 is the number of times its corresponding factor occurs. Multiplicity. All right, number 7, the graph of 5x to the 6th minus 3x to the 4th plus 2x minus 9 has at most how many turning points? Remember, the degree is 6. The turning points 1 less than that. So we have 5. Number 8, tell whether this is polynomial. So if you want to look at it better, I think, if you rewrite it into parts. So this could be 6 over 5 minus 1 over 5 x to the 4th. So there's no problem with the exponent there at all. It is a polynomial of degree 4. Says write it in standard form and identify the leading constant term. So if we put this back with x to the fourth over 5, and we put it in order that way, this is what would go in the first box. And the leading term is this, and the constant is this, okay? So there we go. So the leading term is the negative x to the fourth over 5. The constant is 6 over 5. The whole thing right here goes in that box. Number 9, determine whether that function is polynomial. And we should notice real quickly, it has an exponent of 1/2, and we said that they could not be fractions. Could not be fractions. Number 10, is this thing polynomial? There's absolutely nothing that keeps it from being that. It is a polynomial of degree 5. Write it in standard form. It is in standard form here, so you would write that. The leading term is the 6x to the 5th. The constant is the term that does not have an x, so that'd be a 1/6. Number 11, x plus 1 to the 4th. All right, which transformation is needed to graph that? Well, the 1 being added is inside the parentheses. That's a translation that's horizontal. So that is the one we would choose there. And so if you're looking at these, which one of these shows the parabola looking thing going to the left? It would be this guy, okay? Same thing with this one, y equals x to the 5th minus 7. Now this minus 7 is not in parentheses, so that is a vertical shift. It'll go down. So the graph should be shifted vertically down 7 units. And this is like x cubed, but it's x to the 5th, so that's kind of what it looks like. But this point where it would have hit 0, 0, that's the point that moves down. So if we look here, this is the one that just shifted down on the y-axis. Number 13, x to the 4th, which looks kind of like a parabola. It's just flatter on the bottom. And so it didn't move horizontally or vertically, but it did get changed here. The number out here affects the y value, gets stretched. So this one is -1 3/2, and this one is 1 3/2. So the y value got multiplied by 3/2. Number 14, this transformation went left 3. Remember, inside it's kind of not intuitive. If it's positive, it goes left. If it's positive here, it goes up. So you can figure out which one says that, and then you pick the correct graph. Now this one, I think it's not our last one, close. Form a polynomial whose real zeros are given. So they give you all of the zeros or the x-intercepts. And we need to remember that in a function, the zeros or the solutions, if you're putting them back into factored form, it's always x minus these numbers. So I've got x minus a -2, x minus a -1, x minus 1, and x minus 3. I cleaned those two up, and so I have these 4. Now what I noticed, you could or you wouldn't have to, but I noticed these are the same except the signs. And so that gives me the difference of 2 squares, x squared minus 1. So then I had x minus 3 and x plus 2. If you do FOIL on that, you get this. We'll combine these two. So now I have this and this. If you're going to multiply it, x squared times x squared is x to the 4th. X squared times minus x is x cubed. X squared times a minus 6 is a minus 6x squared. Minus 1 gives you your minus x squared. That gives you a plus x. that gives you a plus 6. And then if you combine the things you can combine, you should get that. 16 would be the same way. You're given the zeros, you know it is a degree 3. We do not necessarily know about the number here, but we do know that the y-intercept is 24. So once we have this written, at 24, your x values are 0. So 24 equals a times 0 plus 2, 0 minus 1, 0 minus 4. So I have these three numbers times a. That ultimately gives me 8a. So now I have a is 3. So that allows you to choose the correct answer. So we needed to know that to come up with that number there. On this one, we've got a polynomial function. You're supposed to A, list any real zeros of f. So these are already in factors, so x would be 6, x would be -5. The multiplicity of the larger one, so the larger one, +6, the exponent there is 1, so that's a 1. For the smaller one, which is -5, the exponent's 2, so the multiplicity is 2. B, the graph, let's see. So the question is saying, does the graph touch, here's your choices, cross or touch at the larger x-intercept? Well, remember 6 is here, that's the larger one. It's an odd degree, so for the largest one, it's going to, okay, I had to correct that real quick. So the graph for the larger one, that it is an odd exponent there, that's going to cross on the x-axis. And for the smaller one, the -5, that's an even, and remember that just touches. So those are the answers for there. Maximum number of turning points. This is a degree 3 because this is an x squared times an x. That gives me x to the third. So we have a degree 3, and it's 1 less than that. Type the power function that the graph of f resembles. So some of these things happen to it, but since it's x cubed, it resembles -9x cubed. Regardless of this changes it, but it resembles this. And I think that gets you going on all your problems for 4.1.